Hello, welcome to the lecture on bloodstain pattern analysis for JS 110 Introduction to Forensic Science. My name is Jason Linville, and this lecture is being recorded in the summer of 2017, July something, 18th, around there. So if you're accessing this archive lecture in future semesters, all the material about bloodstain pattern analysis still applies, but if I mention anything about quizzes, exams, upcoming assignments, deadlines, broken iPads, you can ignore all of that stuff. All right. So for the bloodstain pattern analysis lecture, let me get back to it here. For a lot of these lectures, we begin by sort of describing a crime where the evidence would be encountered as evidence. For, example, with bloodstain pattern evidence, you walk in and there's spattered blood on the wall or floor or ceiling or wherever. And the bloodstain pattern analysis will come in and look at that pattern and help to reconstruct the crime. So here we're really moving away from all of the other types of evidence we looked at, where we were either talking about class characteristics and individual characteristics, or we were talking about presumptive tests and confirmatory tests. And here it's going to be very similar to when we talk about forensic pathology, where you're comparing a situation to how blood normally behaves and how liquids normally behave when they travel, and then you're doing some analysis to help reconstruct the crime scene. So it's not strict class character, trait by trait comparison. Although if you think about it, if you're going to say that it was a blood pattern that was cast off of a swinging knife, you're sort of comparing that to how blood looks when it's cast off of a swinging object. So because of that, I don't think that blood spatter is covered in the mock case questions, because it really doesn't fit well into the class characteristic, individual characteristic thing. But there will be some questions on your normal quiz and normal exams coming up. Excuse me. Okay, so we're going to review blood really quickly, and then we're going to talk about the way the book sets up this chapter is a little bit weird. It talks about some things blood analysts can't do, and then it talks about what they can do. So I follow the book, and it's at least good for an easy multiple choice question. All right, so if you remember from an earlier lecture on bloodstain identification, we talked about how blood, if you're having a birthday and cut your fingers, starts to come out of your skin. And it's because you have these capillaries, veins, arteries all throughout your body. So if your skin is punctured in a violent crime, then blood comes out. And when blood comes out, it's not just when it leaks out of the body onto the floor or the ceiling or the wall, but it can also be a result of an impact with a bloody body. If that what I mean by that is that if I'm bleeding in my face and then somebody punches me or hits me with a baseball bat, then there will be spatter from that. Okay, or it can be like a one-time spatter exiting the body. In the case of a gunshot wound, it's boom, the bullet breaks the skin and blood goes flying everywhere. So it's up to the blood spatter analyst to come in and look at the different shapes and sizes of the individual blood drops, and then sort of group them together as a pattern and help reconstruct the crime, as far as trying to figure out maybe how many blows there were, what direction the impact came from is a big thing with blood spatter. Now, briefly, even though we don't really have a slide of it here, before we get into determining distance blood falls, the people who do blood spatter analysis can vary from agency to agency, and this is like agencies don't have Dexter, which I've never watched a Dexter show, but I understand he's like a blood spatter analyst, and that's all he does, or something like that. I'm sure it's like Bones. There's like one. Well, no, but then he also murders people, so who knows what the show's about. But anyhow, for blood spatter, oftentimes somebody on the crime scene unit will receive additional training through workshops or seminars on how to interpret blood stains, and then they will do that. Sometimes it can be a DNA analyst or a blood analyst from the lab that receives, again, additional training on how to interpret blood spatter, and then they will come out of the lab to assist law enforcement with interpreting blood spatter. So it's just there's not a lot of blood spatter analysts in the United States. It doesn't come up too often, but every once in a while, it's important to interpret the evidence because it can aid in a case, and I'll talk a little bit more about that later. Okay. Number one, determining distance blood falls. Is it possible to determine whether the blood fell off of a knife that was held 6 feet from the ground, being murdered by a giant, or 3 feet off the ground, being murdered by a little person? And what we're going to find is the answer to this is no, but as we go through this question, it's going to remind us, or not necessarily remind us, but teach us about how blood behaves as it's traveling through the air. Okay, the first thing to understand is that blood does not fall. It's not like raindrops that a sixth grader may draw, on a lousy picture where it's sort of that teardrop shape. When blood falls, it forms a sphere, and it falls as a sphere. All right. If it's traveling out of a body, it travels as a sphere. Now, as it travels, it may be distorted a little bit, but it's still important to just think of each blood drop as a liquid ball or a ball of liquid. So when that liquid ball falls and hits the floor, so let's pretend that this is hitting just a clean white floor, it hits and it spreads out, and it would form a perfect circle, okay, if it fell straight down. And the size of that circle would be affected by the speed of the blood drop. Okay, so in theory, if you had two blood drops that were identical in every other single way, except the one was traveling, one fell farther distance and was traveling faster, okay, because of acceleration, then in theory it would hit and spread out a little bit more than a blood drop that fell from a shorter distance and was traveling slower. Okay. The problem is that even though faster drop, larger diameter, higher distance, larger diameter, you can only look at a blood drop and determine what distance it fell from if you knew the total volume of the blood to begin with. And this becomes the reason why this type of determining distance blood falls analysis is not possible. All right, because the volume of blood drops is not constant. In fact, it's highly variable. You can have large blood drops, or you can have tiny, like pinhead-sized blood drops. And a lot of it depends on the type of impact and the certain situation. And sometimes in an impact, you'll have blood drops of all different sizes. If it's dripping off an object, it can depend on the shape of the object. For example, if it's dripping off the end of a blunt baseball bat, it may tend to be bigger than if it was dripping off the very tip of a knife that, a murderer was holding as they were doing their stabbing. Okay, needle small, bat large. All right. So because of this, we can't really measure the distance a drop has fallen. Okay, we're only going to be able to look at direction, which we're going to look in the second section. But it's important to understand that when blood exits a person or exits an object, think of it as a ball of liquid flying through the air, and know that it can be of any volume or of any size. Okay, and then when it impacts a surface, it does hit and spread out. Okay, the type of surface can have an effect on what the blood drop looks at. Okay, we were talking about a very smooth blood drop. Again, if we dropped it from, a knife and let it fall straight down and hit the floor at a 90-degree angle. If we did the same thing on a piece of wood, then it may have this spattered look. Okay, and it may be tempting to go, oh, well, this was traveling slower, this was traveling faster. But that's not the case. What happens is if we look at a side view of a piece of wood that is a very lumpy surface, okay, when that ball of blood comes down, it hits and it may bounce and sort of go farther that way and sort of, think of it dropping a bunch of bouncy balls on a smooth surface. They all go down and come straight back up. But if you throw a bunch of bouncy balls on a rough surface, which we've all done this, haven't we? We just rounded up 100 bouncy balls and then, threw them on a wavy floor. but they would go all over the place. And it's sort of that way where you have this center area where most of the blood falls, but it hits some of that rough stuff and it causes this little like spattered appearance. Okay. But again, bloodstain analysts, they don't really look at that because it's not like they're looking at a blood drop and go, oh, that means the surface is rough. No, you can look at the surface. You're right there. But it's important to understand that the appearance, as far as whether it's spattered or a smooth circle, the bloodstain analyst doesn't look at that. Okay. What the bloodstain analyst does look at and can use to help reconstruct what happened is the shape of the blood. And this is when the blood hits a surface at an angle, which will become important. It actually spreads out and forms an oval, okay, or an elliptical type shape, however you want to think about it. Okay, so notice that this is not a circle, okay, it's like an oval here, and then has a little bit of a splash. Okay, so the bloodstain analyst can look at this blood drop and determine what direction it's traveling. Now, a lot of people look at this and they go, oh, it's traveling in this direction because it's sort of like a comet. When a comet flies through the air, it has fire coming out of it, and it sort of looks like a tadpole, and it's a comet's flying in this direction, right? But remember, we want to think of this as a ball of liquid. So if you think about it, if a ball of liquid was somebody threw a bounce pass of a liquid basketball off of a floor, it would hit the floor and it would splash forward, okay? And it would be smooth at the back and it would be rough at the front. So what we're looking at here in this picture is in the back is where the smooth part is. The blood stain came from this direction, hit, and splashed forward. Okay, so this splashing tells the analyst, oh, okay, the blood was coming from this direction. And I think I have the arrow here. Yeah, there we go. On the next slide. Okay, now that is more or less what a bloodstain analyst does. And then there's some variations on that as far as how they can reconstruct the crime and interpret where that blood stain came from. Okay, all right. It's important to understand that, let's go in the case of a gunshot. Okay, I'm standing in front of a white wall, all right, and somebody shoots me, and the bullet enters my chest, goes out my back, and blood sort of comes out of the wound and splashes against the white wall. Okay, well, there would be a whole bunch of little drops from that one gunshot wound, right? So if the analyst looked, and they would be spread out over a large area, but if the analyst looked at each of those blood drops individually, and they don't have to look at all of them, what they would find is that they all sort of originate from the same point, which is where the bullet exited the body. Okay, so if I, am shot here and you see blood like over a large area, but then the body's moved, okay, the bloodstain analyst can come back and look at these blood drops and say, hey, the wound was actually right here in this area. The person was standing right here when they were shot. Okay. Whoops. So you can determine, and this is a two-dimensional point of origin from just looking at the direction of all of the blood stains in a spatter. Now, what you may find is there may be some other blood drops that originated from a different direction. Okay, what does that mean? It means there were two wounds. Okay, one here that created a set of splatter, and then one over here that created a different set of splatter. Okay, so just looking at a wall or a floor or a pattern, the bloodstain analyst can sort of figure out how many punches, how many knife stab injury, how many gunshots were involved there. Okay, if you get a lot of overlapping patterns, it can be very difficult. But if it's just one or if it's a couple, the bloodstain pattern analyst, can figure that out. Okay, now let's say that this was the pattern, and we determined that, okay, Dr. Linville was standing right here, here that's me, and I'm wearing a dress, I guess, and here, I don't know. Okay. And he was standing right here against this big wall, as opposed to standing over here. He was not standing over here. He was standing right here. Okay, that's a two-dimensional point of origin. But it doesn't answer the question, was I very close to the wall Or was I a foot from a wall? Was I 3 feet from the wall? Was I 6 feet from the wall? Okay. That can be answered by a little bit closer analysis of each individual drop. All right. And the closer analysis is you can determine the angle, more or less. I don't know why I said more or less there, but you can determine the angle here by doing mathematics. Now, I'm not going to give you like a blood stain and have you measure it and take the inverse sine and tell me what the angle is. But what I want you to know is if I ask you on a multiple choice question, how is the three-dimensional direction determined? You can say that it's determined, mathematically by looking at the width and the length. Okay. Now notice here, the width and the length are equal. It's like a perfect sphere. Okay. This means the blood drop hit at a 90-degree angle, which if it was the floor, it means it was falling straight down. If it was against a wall, it means that I was, standing right in front of it and the wound was right here. Okay. If it's oval, then that means that it was a little bit farther away from the wall. Okay, so let's take a blood drop that is oval and right here. Okay, and this is still Dr. Linville right here where I was standing, and the bullet came in sort of at an angle from this way and hit me, and then blood spattered against the wall in this direction. Okay, now if I'm very close to the wall, right, then, and you have to use your imagination here. This is like a children's show. If I'm very close to the wall and it came in, the bullet came in from the left and the spatter went off to the right, then it's going to be very long oval because if you think about it, it really smears on the wall because I'm so close. Okay, but imagine from your computer screen that I'm not very close to the wall, but I'm very far away. Okay, I can be, but I'm sort of the same distance, from here to here. All right. So I start stepping away, walking away from the wall towards your face, off of the computer screen, and you're very frightened. But then if I get shot from the same general direction, the blood drop when it hits the wall is not going to be as oblong because as I get farther and farther away, then all of a sudden it gets shorter and shorter until if I'm sort of infinity far away, although that's impossible, right, for a blood drop to travel infinity miles, then it just sort of gets rounder and rounder. So again, you can sort of tell if I was really close to the surface, then it would be very, long ovals, where if a person was farther away from the surface, then it would still sort of indicate and be oval and indicate that it was going in this direction, but it would be much more circular. All right. Okay, and this sort of shows how the bloodstain analyst can work here. Let me move my chat box up here so I can see the picture a little bit better. Okay, so what they can do is for each individual blood drop, and it looks like here they've picked, let's see here, 1, 2, 3, 4, at least 6. There may be some more underneath there. But they looked at these good blood drops that they had clear, they weren't obstructed or splashed over anything. And they found that they all sort of came from this direction. And then they start to use the mathematics to sort of pull out from that surface to figure out exactly how far away from that surface it was. Again, the closer the impact, these ovals are going to be very long, but if you get farther and farther down the table here, then they are going to look more circular, and this is a terrible drawing there. Okay. All right. Now, there's a YouTube link here that I'll let you guys follow if you want to, or if the link isn't working, because what would it be in? Because you guys don't have the PowerPoint, it's in the PDF, and I don't think it's transferred into the PDF. I'll have to post the link or something. So, yeah, because I can see it, but that doesn't do you guys any good. There, you can maybe read it. But if you type in on YouTube, Science of Murder, Blood Spatter, we watched this in class. It's actually, I think, a couple of dudes. It looks like the video was made a while ago from Las Vegas. Who work on the crime scene unit. They're police officers, and they do blood spatter analysis, and they sort of talk about the rarity of it. And if you want to see I'm sure he's a nice man. an interesting, nice man run along a white piece of paper, bending over and holding a dripping paintbrush, then by all means, I recommend following that link. Okay. So in general, there's an impact. The bloodstain analyst will look at the size, or excuse me, the shape of the blood stain, and then do some mathematics and find out approximately the location from where that blood drop originated. Now, how this can become important in a case is blood spatter analysis came up in the Phil Spector case, which was not too long ago. Philspecter, I think. But so if you look up Phil Spector blood spatter, and that case, I'm going to summarize. I may make some mistakes here, but it was a matter of there was a woman who was shot, and Phil Spector was in the room when she was shot. So that sort of wasn't a debate. What the debate was is whether he was, as he claimed, far away from her and while she shot herself, versus what the prosecutor was claiming, he was very close to her while he had the gun and pulled the trigger. All right. So one of the questions was whether his arms were down at his side when she was shot, and the blood spatter would sort of form a pattern that indicated his arms were down at his side, versus if his arm was outstretched, in other words, holding the gun towards her, then the blood spatter would look quite different. Because you can imagine if he was standing a little, 6 feet away or whatever, and his hands were at the side, the blood would come off of the body and form very circular shapes on both the top of his arm and the chest of his pajamas. Let's assume he's wearing white pajamas. Excuse me. If his arm was outstretched, then the blood coming off of the victim would hit the sleeve, but it would be much more oval-like, and it would indicate that the direction came from the hand direction. In other words, his hand was outstretched and as he was, firing a weapon. So this type of analysis can be done to sort of determine not just the direction that the blood came from, but also the position of surfaces, in this case, the chest and the arms, when the impact was made. Okay. All right, so spattered blood is the type of blood that we're talking about where you have an impact and a bunch of blood circles go flying until they hit a surface, and then they form specific shapes and sizes on that surface. The amount of blood and the amount of force affect the size of blood spatter. So in other words, how big are those little blood circles going to be, and how wide of an area are they going to be spread out? Well, we're going to go through a couple examples here, gunshot, stabbing, and beating, and we're going to look at the resulting spattered pattern from each. Okay. So we already said that it can help determine the location of the origin of the blood source. And by looking at the size of the blood drops and the area that they're spread out over, they can also give you a little indication whether it was a gunshot, blunt force, or sharp force injury. Okay. So we're going to separate this into low impact spattered blood. In other words, a beating. I'm punching you in the bloody face or hitting you with a baseball bat. Versus high impact, which is pretty much gunshots. Okay. Is it possible to look at a blood spatter on a wall and figure out if it's the result of somebody being punched in the face or being shot? All right, with gunshot spatter, because it's such high impact and the bullet is moving at such a high velocity, it results in a mist-like spatter. In other words, it's all of the little blood circles that result from the bullet exiting the body are very tiny. So it sort of sprays this blood, and you can imagine, if you were to spray blood out of a misting like spray bottle, then you would get sort of this mist pattern. Okay. Now, not all gunshots will result in this misting pattern, but if you see misting, then it's most likely a gunshot. In other words, you can't really get that misting pattern just from beating somebody or punching them. Okay. All right. So on the topic of gunshots, they do result in back spatter, meaning, again, let's imagine Dr. Linville standing up against a white wall, the bullet goes in the chest, out the back, and spatters where the bullet exits, which we would be forward spatter, okay, with the bullet. So the forward spatter where the bullet exits, that would hit the wall. But also, if somebody was standing in front of me, holding the gun while they were shooting me, there would be some blood coming out of that entrance wound and would go back onto the suspect. And that back spatter is the type that was being discussed in the Phil Spector case, because they were wondering, okay, he was standing in front of her, he doesn't deny that, the blood came out of the body and went onto his body. The only question was whether his hand was raised or lowered. All right, beating and stabbing spatter, these low impact spatter, give not a misting pattern, but they give larger individual stains. Okay, so the balls of liquid are a little bit larger than a mist. Now, that doesn't mean that they're huge globs of blood that are flying out, but they're just larger than a mist. Also, with beating and stabbing spatters, well, really more beating than stabbing, because with stabbing, the knife goes in, the knife comes out, and you can sort of sling blood around. But with the beating, it's not like in the movies where, somebody gets punched in the face one time and then blood comes flying out of their nose all over the place. Usually you have to have that first impact to break the blood vessels. Okay, so I get punched in the face once and then my blood vessels and my nose is broken, the blood starts to flow. And then it's the second impact is where the spatter and the blood starts coming out. Okay, so it's important to understand if it's just a one punch, then you could break a bunch of blood vessels. The person may fall and start bleeding onto the floor, but you're not going to get a bunch of spatter all over the place. Okay, so the blood spatter there is what the analyst typically looks at. Please, sorry, I'm getting a warning message here. I think the warning message more or less boils down to, is somebody watching YouTube in your house? The answer is probably yes. In addition to the regular spatter, there's something called satellite spatter. And this is, if you can imagine, I'm trying to think of the situation here. So if it's a stabbing, somebody's stabbing me to death, and there is some blood pattern on the floor from the stabbing, the impacts, okay, and then the person starts walking around with the knife and blood is dripping off of the knife, then you sort of have this dripping blood that could be from a knife. It could be dripping blood from somebody's face that's walking around holding their nose, but the dripping blood can actually fall on top of the blood spatter that we just got finished talking about. And the blood stain or blood pattern analyst wants to make sure that that satellite spatter doesn't interfere with their blood stain interpretation. In other words, they recognize that this blood is from a moving, dripping object or person, and that will allow them to also reconstruct the crime as far as where did this person walk or go to, but it's not the same as that impact, from a gunshot or a punch, where it creates all of these balls of liquid. This tends to be just one at a time, and you're trying to figure out where it came from. Okay. Cast-off pattern is something similar. With cast-off pattern, it's not a bunch of little liquid balls from one impact, but imagine you're swinging a knife through the air that has blood on it. Well, as you swing it, there may be 7 drops that come out off of it, but they all come off of a different time. So you start to swing it and one blood drop flings off the tip. You continue swinging it off the 2nd, 3rd, 4th, 5th, 6th, 7th. And those 7 drops will create sort of like a line on the wall or the ceiling where you can sort of reconstruct the movement of that object that had blood on it. Okay, so this is called cast-off pattern. Again, it's not the same as an impact where it's one impact and then a lot of liquid balls go all over the place from that one point of origin. The cast-off pattern has multiple points of origin. Okay, but they all fall in a line of the swinging object. All right, expirated bloodstain pattern. Really, remember before when we talked about misting, we said it means it likely came from a gunshot or almost always came from a gunshot. There was this one case where Henry Lee, I think he was testifying that a misting pattern at a crime scene might not be from a gunshot, and it might have been from a victim choking on blood. So I think he like snorted red water and then like blew it out of his nose onto a white board in front of the jury or something like that. But expirated bloodstain pattern, it refers to this blood that is being coughed up or sneezed out. Okay, and it can create, large balls of blood and look like a beading pattern, or it may be possible to create a misting pattern from sneezing up, blood. Now you may think, oh, well, when is blood ever going to accumulate in the lungs? Well, if you have a facial injury and you start bleeding a lot, then it drips down the throat and it does get in the lungs. And it's not uncommon sometimes for individuals when they die of a beating to die of drowning, essentially drowning in their own blood, because the blood drips down and gets in their lungs and prevents them from breathing. Okay. If you want to determine whether it is expirated bloodstain, you can look for some saliva or nasal secretions mixed in with the blood, but that's not, as we've already gone through, that's not an easy test. I mean, I guess you could do some Fattibus test, but it's not quite as sensitive as some other tests. Okay, other things you can do with blood spatter is, number one, the alteration of a blood stain over time. Like you can see here, this is a blood drop on a smooth surface that had started to dry on the edges, and then somebody stepped in it and smeared it. So this indicates that the blood drop was there for a while and then was disturbed. Okay, so it's not as though the person was shot or stabbed and then they fell to the ground and then nobody else was walking around. This indicates that that blood was there for a while and then was interfered with. All right. You can also imagine, like, if you came upon a blood stain on a floor and there was like an empty space in the middle that was the shape of a key or something like that. Somebody came and picked up a key out of this blood, and because it clots and hardens, it doesn't necessarily, pool over where you pulled the object out. Okay. Now, a lot of people try to look at a blood stain and analyze it to try to determine how long the blood has been outside the body. In other words, if you come in and you find somebody shot 3 times and a bunch of blood drops on the wall, if you can determine that those blood drops have been there for an hour, then that helps you pin when the gunshot occurred and when the murder occurred. If they'd been there for 5 hours, then that also would help with the investigation. But all of the type of analysis looking at this aging of blood stains, there's so many variables, it's really difficult to get an accurate answer for that. Okay. And let's see here. Clotted smears can indicate time of movement, like we looked up there, as far as the blood starts to clot, and then you have a smear. Okay. I think that might be, yeah. Okay, so that's it. So with blood spatter, it's sort of the big thing where looking at a bunch of blood balls from an impact and reconstructing where that impact came from, both 2-dimensionally and 3-dimensionally. And then whether you can tell something is a beating blood pattern or a gunshot blood pattern. And then some of the extra ones, satellite, cast off, expirated blood pattern, and then just recognize that blood is not just like a normal liquid, it tends to clot, and that can give investigators some information as well. So you'll notice what we didn't talk a lot about is class characteristics, preliminary tests, confirmatory tests, individual characteristics. It's all more or less just understanding how blood behaves and then helping that assist your investigation. Fluid dynamics. Okay, so at this point, Garrison, Melanie, if you have any questions, throw them in the chat box and I'll be happy to answer them. I'm sorry we didn't have a lot of audience interaction tonight, but then again, it was a little bit shorter lecture, so I guess it's a good one to choose to attend to get your 5 points for. And I have you guys both down for attendance, so you can jump out of the room at any time and you will still get credit for the lecture. And then I will stop the recording here in a second. And if you guys want to ask me any questions that you don't want to have as part of the recording, you'll get a chance to do that too. It sounds like somebody's screaming out in the other room. So with that, I'm going to stop recording. Okay. Yeah, thanks guys.